Hello and welcome. It's your main math man, Mr. Lyons here. And we are currently on page 75. And we're still solving systems of linear equations. And when we solve systems, what do our answers look like, right? When we solve systems more than one equation, it's where the lines intersect at a coordinate. Let's not forget that. What do you think is different about this system compared to the ones that we did on Tuesday, the ones that we did on Monday, right? On Monday, we had opposites to eliminate. On Tuesday, we had to multiply an equation to get opposites. But here now, we're going to have to multiply both equations to try and get opposites. That's right. That's why we had that lowest common multiple activity at the beginning, right? And the most efficient way to do that is to look at what's the most efficient variables to cancel out. So 4 times 7 is 28. 2 times 3 is 6. I'd rather deal with 6 than 28 because those are going to be lower numbers, easier numbers to calculate. So I'm going to deal with my y coefficients here because these are the lowest multiples compared to 4 times 7 is 28. So 2 times 3 is 6, so that's going to be my lowest multiple here. Now I have to figure out how do I get opposites, right? I have positive 2, negative 3. I want positive 6y, right? And in order to eliminate that, I'm going to need negative 6y, right? What do you need to multiply the top equation by to get 6y? What do you have to multiply the bottom equation to get negative 6y? Think. That's right. I'm going to multiply my top equation here by 3. So the top equation is going to be 3 times 2 to get that lowest common multiple of 6, right? Go ahead and distribute like usual. You already know the vibes. Fill in this before I fill it in. It's going to be positive 12x equals, what's 14 times 3? If you got a calculator, do it before I do, please. I know 10 times 3 is 30. 4 times 3 is 12, so that's going to be 42. Now I have positive 6y here. Now I need to get negative 6y at the bottom. So what am I going to multiply my bottom equation by, right? We're trying to eliminate variables, right? So we're going to multiply that whole bottom equation by what? By 2, right? So it's going to be 2 times 3 is going to give us 6, right? And so I'm going to distribute here. Don't forget to show you the distribution. I know you guys can do this. It's really the organization that takes place. Go ahead and write in your new equation. Positive 14x. We have negative 6y, negative 16. Now I can eliminate my what? My y's here, all right? 12x, 14x is 26x equals, what's 42 minus 16? Do that on your own. Absolutely, you should get 26. Here, you're going to just divide by 26, divide by 2. You can, I know we're comfortable at this point, right? X is equal to 1. But that's not my final answer because now that I have x, I can go ahead and calculate my, that's right. Go ahead and find your y. If you can do this on your own, pause the video, see if you can do it on your own, right? I'm going to use my top equation, substitute 1 for x, 4 plus 2y equals 14, minus 4, minus 4, pause the video if you feel comfortable doing this. 14 minus 4 is 10. Divide by 2, divide by 2. What is y equal to? Y is absolutely equal to 5, right? But this is also not the last step. You might say, oh, yeah, I got my answer. No. What's the last thing you have to do here? Be honest with yourself. You have to check your work. That's right. That's always a good step you got to do. Since I use my top equation, I'm going to use my bottom equation now. Just rewrite your bottom equation. Pause the video. See if you get it. See if you can do this on your own. 7 times what? 1 minus 3. Remember, Saunders? Make sure you check your variables. My y is actually 5. 7 minus 15. I know 15 minus 7 is 8, but I have more negatives. It's going to be negative 8. Equals negative 8. Bada boom, bada bam. What's your answer? They're going to intersect at 1, 5. On the next slide, plug in these systems. Plug in this equation, plug in this equation. See if they actually do intersect. On the next slide, use Desmos. See if they actually intersect here, okay? And they should intersect at our coordinate. That's our solution, okay? After you plug in those, you're going to check in on the fill in the blank. Same thing. The only new addition is that you're multiplying both equations today to create opposites, all right? Much love, and I'll check you in the next video.